So starting now with atomic structure, what is an atom and what's the structure of an atom? That's what we're going to study. So the first thing is, I mean, I'm going to give you, I'm going to draw an atom. You pretty much know what it looks like. An atom has a nucleus, which is at the center, and it has electrons that are in shells that are around that particular nucleus. Here, let me set this right. So this is what normally an atom looks like. The protons and the neutrons are in the nucleus of the atom, that's the center, and the electrons are all roaming around. I mean, the first shell has just one electron, so they're all roaming around the nucleus. They're attracted to the electron. So it's like uh, it's like you have a positively charged nucleus because it has protons and neutrons. And protons are have positive charge, neutrons have no charge. So which is why the nucleus of the atom is positively charged. So the center of the atom is a positively charged nucleus, and it attracts electrons all around it. So it's like a magnet that where the nails are sticking to the magnet. So there's an electrostatic force of attraction that is pulling the electrons. So all the electrons are getting attracted to the nucleus. So there's an electrostatic force of attraction which is attracting the electrons towards the nucleus. So electrons are attracted to the nucleus by and chemistry in chemistry there is only one force of attraction, and that is an electrostatic force of attraction. So I'm going to talk about this electrostatic force of attraction in a while. So it's the force of attraction that is between charged particles. Uh, there's three main forces around you. There's the gravitational force that's between masses. Uh, there's a magnetic force, and you have an electrostatic force that's between charged particles. So this is what a typical atom looks like. The nucleus, and you've got shells, and those shells, they contain electrons. So that's what a typical atom, or almost all atoms, they kind of look like. Uh, uh, Nucleus with electrons sticking to that nucleus. So starting with the very basics, an atom is the simplest building block of matter. An atom is the smallest building block of matter. So you have atoms all around you. An atom can be broken down into smaller particles, which are protons, neutrons, and electrons. Uh, but this is the main building block out of which. So every molecule, every substance that you see, it's a combination of atoms that are all joined together or bonded together. Uh, so an atom can be broken down, and they do it a lot. They try to break these atoms down into smaller and smaller pieces to try and figure out how many subatomic particles they are. So you have proton, neutron, electrons. The protons and neutrons can also be broken down further into even smaller particles. There's a large hadron collider somewhere in Europe where they collide these particles at high speeds. Try to figure out what would happen if a proton is bombarded with another proton, and if the proton splits up or the neutron splits up, how many different particles could there be? So you get all sorts of particles, uh, but we're going to stick to proton, neutron, electrons. But remember, they can be broken down as well into tinier pieces. Now, the first thing is you need to know what the charge of each one of them is. So an atom consists of proton, neutrons, electrons, and the relative charge of a proton is +1. Similarly, the relative charge of a neutron is 0. It has no charge. So neutron is neutral. And the relative charge of an electron is -1. So protons and neutrons, protons and electrons, they kind of have the same charge, but it's opposite. One is positive, the other one is the other one is negative. Then you have the relative mass. The relative mass is the proton has a relative mass of 1. The neutron also has a relative mass of 1. And the electron is really tiny. It's 1 over 1836. So it's a lot lighter than a proton and a neutron. What I mean by relative mass is 1 is not the actual mass. 1 simply means that whatever the mass of the proton is, the neutron will have exactly the same mass. And the electron would be 1 over 1836 times lighter. So it's basically a comparison that these two have the same mass, and this one over here is much lighter. The actual mass of proton, like if you let me just Google proton. 1 second, proton. Let me just try and find. Let's look at a neutron. So it would be the actual mass of a neutron might be given over here somewhere. So it's 1.67 times 10 power minus 27 kg. So that's a very tiny mass. So it's provided over here, this one. So just remember, we don't, because the number is it's so tiny, you don't actually talk about the mass of a neutron. What you instead talk about is the relative mass. That neutron has a mass of 1. So the proton has exactly whatever the mass of neutron is, the proton is going to have exactly the same mass. And the electron is going to be 1836 times lighter. So that's the first thing. You have to know this table. So that's the first thing. The second thing is, hopefully everyone knows that like charges they attract. Sorry, like charges they repel. And if you have unlike charges, they are going to attract. So positive is going to attract. It's going to attract negative. But positive and positive are going to repel. So they're going to repel each other, and negative are also going to repel each other. So, for example, two electrons, they are going to remain as far away from each other as possible. Similarly, protons would try to repel other protons, but protons and electrons, they are going to attract each other. Protons are positive, and electrons are negative. This force of attraction is known as the electrostatic force of attraction. So in chemistry, that's the only force of attraction. Whenever you think of a bond, whenever you think of any attractive force, uh, the only force of attraction that exists, that's this electrostatic force. So remember, gravitational force, magnetic force, they're going to be studied in physics, but electrostatic forces of attraction are going to be studied in chemistry. I mean, all the forces that we're going to study, all the chemical bonds that we're going to study, they're basically a force of attraction between positive and negatively charged particles. Okay. So is this clear?
Yes, sir.
अच्छा ठीक है. Uh, चलिए ठीक है. Did anyone else have any problems joining the meeting? I don't think so. अच्छा, so moving on. So you've got a bunch of protons, neutrons, and electrons. So the first thing is we're going to try and figure out how many protons, neutrons, and electrons does an atom have. So you've got your periodic table. And every periodic table has two things written next to it. So I'm just going to open up a periodic table, and you can simply type AQA periodic table if you want to. Uh, if you want to find a periodic table, just type AQA. I mean, this is what I searched. Uh, Keep one with you. You can print it out. So AQA periodic table. This is so you're going to get a similar periodic table in your exam, and this would be with you, so you don't have to memorize this. One thing with periodic tables is it's the position of the numbers. Uh, every atom or every element that you have, uh, it's going to have unique numbers written next to it. And these numbers are, their position might be different. I mean, every periodic table is different so just be aware of that. There's a key given. So I'm just going to write that every periodic table, the element would be X, the atom would be X, and it's going to have two numbers next to it. So let's say there's a number B and there's a number A. So ignore the position. Uh, I mean, B could be over here, A could be written over here, or it could be some periodic tables B and A are both written at the bottom. The A could be written at the top. So we don't really care. What you should know about these two numbers is that there's going to be a smaller number. I mean, the reason I'm saying this is because they keep changing periodic tables a lot, and the position of these two numbers, it kind of keeps changing. And even in your exam, there's a very bright chance that if somebody runs out of a periodic table and they ask the examiners to go and find them a periodic table, they might just print a random periodic table from the internet. So the position of the numbers could be it could be all over the place. So I'm just going to tell you that there's a smaller number, and there's a bigger number. I mean, there are two numbers that are written. So think or remember these two numbers like this. Just because the periodic tables keep changing, and the positions of these two numbers, they keep changing. So smaller number, bigger number. Uh, so you can have a look at any element. Boron, there's a smaller number and there's a bigger number. Ignore the position. Okay, don't think of it in terms of position. Uh, so there's a small number, big number. So when you have a big number, the big number is basically it's known as your atomic mass, or more specifically, it's known as your relative atomic mass. And simultaneously, it's also known as your nuclear number. So, so the big number is your relative atomic mass or the nuclear number, and the smaller number that you have, that's known as your atomic number, or it's also referred to as your proton number. So the smaller number is basically it's basically your number of protons. I mean, that's what this number tells you. It simply tells you how many protons you have. So that's the number of protons. And the bigger number, which is the nuclear number, that's the number of protons plus the number of neutrons. So this is the meaning of the two numbers. The bigger number is protons plus neutrons, and the smaller number is just protons. Okay, so remember that. So I'm just going to pick or just take a snapshot of random elements, and we can try and figure out how many protons, neutrons, and electrons does each of the element have. So for example, this one over here. So the first one is let's look at nitrogen. So small number, that's the small number is the number of protons. So it's got 7 protons. And the small number is this one. Carbon has 6 protons, boron has 5 protons, aluminum has 13 protons, and so on. So the small number is your number of protons. How do you find the number of neutrons. The number of neutrons are found by just subtracting the two numbers, because you had two numbers. You have protons and you have protons plus neutrons. So if you want to figure out the number of neutrons, just subtract the protons from this number and you're going to get the number of neutrons. So whenever you want to find the number of neutrons, it's you subtract the two number, it's going to be 14 minus 7 neutrons. So always remember that. This is number of protons. Number of neutrons is you subtract the two numbers and you get 14 minus 7, which is 7 again. And what is the number of electrons? The number of electrons is usually the same as the number of protons. So the number of electrons is the same as the number of protons for a neutral atom. A neutral atom is one which doesn't have a charge. So for a neutral atom, it doesn't have a charge because the number of protons and the number of electrons are exactly the same. You've got plus 7 positive charge over here, you've got minus 7 positive charge over here. So the total charge on the atom is exactly 0 because the charges, they can cancel each other out. Uh, can anyone quickly tell me what's the number of protons, neutrons, and electrons for phosphorus? What's the number of protons? First one. क्या होगा?
15.
ठीक है. So that's 15 protons. And what's the number of neutrons?
16.
16. You subtract the two numbers, that's the number of neutrons. And the number of electrons is usually the same as the number of protons. The reason you have to be careful about electrons is you have to be ensure that because only one thing would change in an atom, and that's the number of electrons. Why? Because if you look at an atom, the electrons are the ones that can be lost and they can be gained. I mean, the electrons are the ones that are sticking to the nucleus. So the nucleus is kind of pretty stationary. It doesn't really change a lot in an atom. The electrons kind of, they get lost. You can lose electrons. You can also gain electrons. So ions are always forming. So the electrons kind of, they can increase, they can decrease as well. So you have to ensure that the atom is neutral. Otherwise, the number of protons and the electrons are not going to be the same. I said this one. Can everyone tell me about arsenic? How many protons?
33.
Okay, that's 33. And how many neutrons?
42.
Okay, that's going to be 75 minus 42. Are you sure? It looks like 42. Yes. So you've got 42 neutrons and you've got 33 electrons. So just remember, because don't go for the position of the number. The smaller number, just remember the smaller number, even if it's at the top, the smaller number is the one which is the number of protons. And I can actually show you that the periodic table, the position keeps changing. Like if I open another periodic table, uh, for example, if I open the A levels periodic table, so you would see that the position of the numbers has changed somewhat. Like over here, the smaller number is actually at the top. Over here, the smaller number is actually at the bottom. So just ignore the position. Don't go for, a lot of people think about position like the one that's on the top, the one that's at the bottom. They keep changing. So ignore the position. Just think of it in terms of the smaller number and the bigger number. So smaller number is the number of protons, bigger number is the number of protons plus neutrons. So anyway, so you can figure out the number of protons, neutrons, and electrons. Always remember uh, that the number of protons are equal to the number of electrons only if the atom is completely neutral. Otherwise, the electrons can be lost and they can be gained. So then you'll be asked to draw to write the structure of or to write the electronic configuration. So I told you that electrons are in shells. So you have a nucleus. The nucleus is positively charged. So there's your positive nucleus. It's got your protons and the neutrons. They all uh, they're tightly packed in that nucleus, and you've got a bunch of shells, and these shells hold the electrons. Now the shells are not a physical thing. They're not a physical thing. It's just like uh, I mean, these are spaces around the nucleus where the electrons are sticking to the nucleus. So there's another region where a bunch of electrons would be sticking to the nucleus, and so on. So let's draw a couple of. I said anyway. So an atom can have many shells. So uh, theoretically you can or hypothetically you can have as many shells as possible, but most atoms, they have a limited number of electrons. So the first thing is electrons would always occupy. Remember, the nucleus is positively charged. So think of a magnet that's attracting electrons. The electrons are always going to occupy spaces which are very close to the nucleus. I mean, first the spaces around the nucleus are going to fill up, then the ones that are around further away, then further away. So electrons always occupy spaces closest to the nucleus, or occupy shells closest to the nucleus. That's one thing. So you don't start filling the last shell. You start off by filling the shell that is closest to the nucleus, and that's how shells are numbered. Shell 1 is the one that's closest to the nucleus. That's also known as the K shell, or we can call it shell number 1 and put K in the brackets. Then you've got shell number 2, which is the second shell, obviously, and then that's the L shell, and so on. Then you have shell 3, which is the M shell, and shell 4. Let's write 4 shells. And you've got shell number 5. So you have 5 shells around the nucleus, and you can go on. I mean, there could be 6 shells, there could be 7 shells. Uh, so you can keep adding shells. Now, one thing you would notice is that as you move further away from the nucleus, the size of the shell increases. Like the first shell over here, it doesn't really have a lot of space around it. So you can have a maximum of 2 electrons. As you move further away, if you look at shell number 2, this one over here, this one is slightly bigger and it can accommodate more electrons. It has more room available in it. And then you have this shell number 3, so that's even bigger than the previous one. So it's kind of it would have more room for electrons. So one formula, how do you know which shell has how many electrons? Now the way you can figure that out is, I mean, either you can remember it. Okay, so let's write that down. The first shell is the smallest one, so it can have a maximum of 2 electrons. You run out of space after filling 2 electrons. The second shell has a maximum of 8 electrons. The third shell has a maximum of 18 electrons. The fourth shell has a maximum of 32 electrons. And so on. The fifth shell is even bigger, so it can accommodate a maximum of 50 electrons. So the shells kind of become bigger and bigger. So the number of electrons that they can accommodate, it also increases. It becomes bigger and bigger as well. And there's a simple formula that you could use, and that formula is 2n square. What that formula means, it means that where n is the number of shell, so it's the shell number. That is what n is. Uh, so if you can't remember this, you can simply put you can just remember n, or 2n square. You can, if you want to know how many electrons can be accommodated in the fifth shell, so just put 5 over there. So it's going to be 5 square is 25. 25 into 2 is 50. So that's the number of electrons that different shells are going to occupy. Is this point clear to everyone? Ashita, is this clear? Amna? ठीक है
Yes,
साथ.
sir.
Okay. So, but now here's the thing. The thing is that if I open the periodic table, now you've got very big atoms, right? Very big atoms are going to have 50 electrons or 100 electrons. Like if I open the periodic table, you can see these atoms over here, right? Like the ones at the bottom. Uh, I mean, the ones that have really weird names. Uh, like flerovium, it's got 114 electrons, so that's a lot of electrons. So you need a lot of shells to accommodate those electrons. Uh, Even lead is kind of a big atom. It has 82 electrons. Uh, so a lot of big atoms, they have a lot of electrons, a lot of neutrons, and a lot of protons in them. But the thing is that big atoms are not very stable. Like if you talk about radon or if you talk about any of these, they're not very stable because if an atom is really big, then it's very hard for it to control so many neutrons and protons and electrons and keep them together. So, for example, there might be uranium somewhere. It's 292, probably. Uh, I mean, a lot of these big elements, they're very unstable. The bigger the element, the rarer it's going to be. The smaller the element, the more abundant it's going to be. For example, hydrogen and helium. Hydrogen is probably one of the most abundant elements in the universe. Why? Because it's a very simple atom. It only has one proton and one neutron. So it's an atom that's very stable. You just have one proton in the nucleus and you've got one electron in the outer shell. So so there's not much going to happen. It's not going to it's going to be very stable. So bigger atoms that have so many protons and neutrons and electrons, they're very hard to form. And so as the atom size becomes bigger and bigger, uh, as the atom size becomes bigger and bigger, sorry, अच्छा so ये यहाँ पे थे. So my point was, okay, all these big atoms, they're kind of very unstable and they're not very abundant. You don't see them much. Most of the atoms that you are going to talk about or deal with are the ones in the first few rows. Uh, Maybe up till this point. That's where you see most of the atoms. For example, I mean, you can see gold over here. Gold is kind of rare. You don't find a lot of gold, so big atoms are kind of rare. You don't see them very often, but you see these small atoms a lot. You see oxygen, you see nitrogen. So most of the chemistry that you're going to talk about and you're going to study, most of the chemistry revolves around these small atoms. You start off with hydrogen. That's probably it's going to be everywhere. Carbon is very abundant, nitrogen is very abundant. 78% of the Earth's atmosphere is nitrogen. The rest 21% is oxygen. So these tiny elements, sand is kind of it's a compound made of silicon. So we'll most of the elements that we're going to study, it's the first two or three rows. That's it. Uh, which is why you don't need. I mean, you're not going to go till shell five. You're not going to go till shell four. Most of the electrons, since you're talking about small atoms, the only number of shells that you need would be one, two, or three. That probably the first three shells. Even they would not be occupied. So, which is why you don't need to know all of this. I mean, there are two ways of actually solving this. You can get two questions. One is you might be asked about the electronic configuration of small atoms, which are the first few rows. And then sometimes you're also asked about electronic configurations of big atoms like iodine or astatine. So you get two different questions, and there are two different ways of actually writing the electronic configuration. So let me get back to this. Just one second. I've lost the board. As I said, you've got a bunch of shells. And the first thing we're going to do is we're going to learn how to write the electronic configuration of small atoms. or drawing these atoms, writing electronic configurations of small atoms. And when I mean small atoms, I'm basically talking about atoms that have proton numbers less than 20. So, what I'm going to teach you, this would only apply to atoms that have proton numbers less than 20, which means up till calcium. Okay, so this, whatever we're learning right now, the electronic configuration, how to draw the structure of the atom, would only, you'll start off with hydrogen and you can only apply it till calcium. That's it. After that, you have big atoms. For that, we're going to learn something else, how to write the electronic configuration of bigger atoms. But anyways, so how do you write the electronic configuration of small atoms? First thing is you don't need these many shells. I mean, you don't need to know, for small atoms, you don't need to know shell number 5, because small atoms, they just have a maximum of 20 electrons. Okay, and I can write that. Small atoms can have a maximum of 20 electrons. So you're never going to see shell number 5 for small atoms. So the way to do that is, there's a rule that's called 288. Just think of this. For small atoms, don't worry whether the third shell has 18 electrons and the fourth shell has 32 electrons. Don't worry about that. For small atoms, what you just need to know is fill the first shell with 2 electrons, the second shell with 8 electrons, the third shell with 8, and just keep going with 8 electrons. I mean, you're going to run out of electrons anyways. You just have a maximum of 20 electrons. So you don't need to know shell number 4 or shell number 5, because they're never going to be filled. So just think of it as 288. So I'm going to draw the first small atom. I have, let's talk about nitrogen. That's 7 and 14. So it has 7 protons and 7 neutrons in its nucleus. And it's got 7 electrons. So the electronic configuration is that you're going to fill the first shell with 2 electrons and the second shell with 5 electrons. And then you're going to run out of electrons. So you don't, I mean, there's no shell number 3, there's no shell number 4, no shell number 5. So just think of 288. Just fill it with, first, fill the first one with 2, then 8, then 8. So in this case, it's going to be 2 and 5. So there's going to be 2 electrons in the first shell, and there's going to be 5 electrons in the next shell. So it's 2 and 5. That's it. A slightly bigger atom would be, let's talk about chlorine. Let's try and draw chlorine. Now, chlorine has 17 electrons. It's 17 and 35. Now, for this, what you're going to do is, again, you've got 17 protons, 17. The difference is, what's 17? What's 35? That's 18 neutrons. And the number of electrons is 18 as well. So, how do you write 18? Not 18, sorry, 17. So, the number of protons and electrons are exactly the same. So, how do you write 17 electrons? The first shell is going to have 2 electrons, and then it's going to have 8 electrons, and then it's going to have 7 electrons, and then you're going to run out of electrons. So just think of 288, just try and fill 288. So it's going to have 3 shells. So here are the 3 shells. The protons and neutrons are in the nucleus, so it's got 17 protons and how many? 18 neutrons. And 17 electrons are going to be filled in this way. It's going to be 2 in the first one, 8 in the second one, and there would be just 7 electrons in the last one, and you're going to run out of electrons. So that's 7 electrons in the last one. That's it. So again, I'm just going to recap. How do you write electronic configuration of small atoms? The ones that have protons less than 20 and that can have a maximum of 20 electrons. For small atoms, just simplify things. Just follow this 288 rule. First one with 2, then 8, and then whatever is remaining would be going into the third shell. So just follow 288. Uh, for bigger atoms, shell number 3 and shell number 4 and shell number 5 would be occupied, but right now you're not worrying about bigger atoms. You're only worrying about smaller atoms, and smaller atoms are more abundant, and their chemistry is the one that we are interested in. Bigger atoms are rare, and that you don't really find them that much. So, but we're going to learn about writing electronic configuration of bigger atoms as well. So is this all clear? Turan, is this clear? Adil? Saneem, is this clear?
Yes, sir.
I said just a small exercise. First 20 elements. Right, draw the first 20 elements. You can do the same thing what I'm doing over here. I mean, just write the number of protons, neutrons, and electrons, write the electronic configuration like this, and then draw the atom. Okay, for the first 20 elements. So I'm going to make an assignment on Classroom and post the answers over there. Okay. So let's talk tomorrow, and we're going to talk about how to write the electronic configuration of bigger atoms tomorrow. Is this clear? Sound clear? Amna, is this clear? Saneem, Turhan?
Yes, sir.
So let's talk tomorrow then.
Yes, sir.
Okay, then take care, everyone. Allah Hafiz.
Officer.
Hafiz.
Yes, sir.